but not right now. All right, so we're going to sketch this. Here we go. So, the first thing that we recognize here is that our equation is ready to graph. And in a moment, I'm going to do another example that's not ready to graph. But this one is, so we're ready to start putting things in. So we know we have a sine curve, but it's negative. So it's going to have to be upside down. So as a little reminder to myself, put that up there so I know that's the shape I'm shooting for. Got it? Now, this sine curve has been shifted to the right. Does everybody see that? Where is the number, what is the number that shifts it to the right? Pi over 3. So it's over here at pi over 3. So I have a negative sine curve that begins at pi over 3. The phase shift is pi over 3. Positive pi over 3. Went to the right. Now, it has an amplitude of 2. It has a period of what? 2 pi divided by a fourth, or 8 pi. This number divides the period. Okay, kids, that's how it's done. Now that means that from here to here is 8 pi. The distance is 8 pi. Let me see if I have to complicate that. Nope. The distance from here to here is 8 pi. This is not 8 pi. How would I find out what that is? Add 8 pi. So pi over 3 plus 8 pi, which would be 25 pi over 3. 8 and a third. A third plus 8. Halfway in the middle is the average of 1 and 25. 1 and 25 makes 26, and half of that is 13. 1 and 13 is 14, half of that's 7. And 13 and 25 is 38, and half of that's 19. Everybody okay? Except for one thing. What do I still need to take care of? The vertical shift. So I have to take every point on that graph and lift it up 1 unit. The vertical shift, the vertical shift is 1 unit. So everything's going up 1. So the red is the answer to the question. Okay?
I did.
I did. What now?
That flips it.
That turned it upside down. The frequency is the reciprocal of the period.
I got it, Mr. Ward.
Now, I'm going to graph another one here. I'll put another one up here, and we're going to do it. Let's do a cosine.
It's like always 2 pi. Unless it's, wait, did you say
Cosine.
oh, then it's pi too. Like pi also.
That's what I'm doing.
Now, this equation is not ready to graph yet. Who remembers why it's not ready to graph? This is extra practice. Tomorrow you are going to have to do at least 1 sketch. So this is extra practice. Everyone's paying attention. So we're going to take out that 2. And when I pull that 2 out, I am not going to get all upset or worried. I'm going to take my best guess as to what I think goes in there. What do you think goes in there? 5/16. Now, before I move on, I'm going to double check that. If I multiplied it back, if I took 2 times this, Would I get that, what I started with?
Yeah.
Yes, so I'm correct. So now I have a cosine curve, positive, that starts at negative pi over 16. Audrey? You paying attention to me? What's on the iPad? Math? I'll turn off. Thank you.
Seriously? I've never seen any minutes ago.
Now, we start at negative pi over 16. It's a positive cosine curve, so I'm just going to sketch it in. Looks like that. Amplitude is 1/5. What's my period? What's the period of this guy? Well, the period's supposed to be 2 pi, but didn't it get divided?
Yeah.
So now the period's only pi. That means the distance from here to here is pi. So how will I find this label? Negative 1/16 plus 1, which would be 15/16 pi. Yep, that's exactly right. Now, right in the middle is the average of negative 1 and 15. Negative 1 and 15 is 14, and half of 14 is 7. Negative 1 and 7 is 6, and half of that is 3. Obviously my scale's off, but if everything's labeled right, you're okay. 7 and 15 is 22, half of that is 11. What's the phase shift?
Pi over 16.
Negative pi over 16 or left pi over 16. What is your vertical shift?
None.
There isn't any, 0. 0's fine, or none, doesn't matter. What's your amplitude?
1/5.
1/5. What's your period? Pi, frequency.
1 over pi.
Okay, everybody got that? 1 over pi, the reciprocal of the period. Okay, everybody got that?
One question. See, I can
Phase
do
shift
graph
is negative
this
pi over
without
16.
it.
The last point, how'd you get the last point? 15 pi over 16?
I already know. It's only the first basketball.
Now, let's finish going over the quiz. And then we are going to, we got one more thing to talk about, and then we'll do some more practice problems. But here we go. Finish going over the quiz. What is the period of y equals 4 tan 3x? Pi over 3. Kids, the period, there's 6 trigonometric functions. The period of all of them is 2 pi except tangent and cotangent. And their standard period is pi. So this number in this position in every trigonometric equation you look at divides the period. The period you start with in a tangent problem is pi, so this period is pi over 3. Got it? We shouldn't miss that ever again. Okay, now we're going to have the radius of the circle. We're going to find the radius of the circle. We got the central angle, and we've got the arc length. Arc length.
Wait, is this for?
Yes.
Is this supposed to be our test? I think that's a different quiz.
Oh,
Yeah.
I picked up the wrong quiz, sorry. Okay. All right, so now we'll start over.
That's tomorrow's quiz?
No, that was first period's quiz. Let's see, but it's close. This is 2 pi over 7, and this is 10. Does that look better?
Yeah.
Yeah.
Okay. So arc length still equals radius times radians. So 10 equals the radius times 2 pi over 7. This should be a no-brainer, but some of you can't solve that equation. So just do it in 2 steps. So you can't, if you're struggling with 1, do it in 2. Multiply both sides by 7. You got to get rid of that 7. So you have 70 equals r times 2 pi. Now divide by 2 pi. you have 35 divided by pi is your radius. That's your answer.
So pi can't stay in the denominator.
Yes, you can't get rid of it. I get what you're saying, Jared, we don't like your rational numbers in the denominator, but there's no way to rationalize it. Like with a radical, you can multiply by the square root or something. If you multiply pi by, what are you gonna multiply by to rationalize? You can't, so it's just 35 over pi.
Mrs. Ford, why, since 2 goes into 70, why wouldn't it just be 35 pi? Like, why is it 35 over?
Where's the pi?
On the, so it has to stay on the bottom, like you can't just not like move up, like not be
Well,
a fraction.
heavens no. I mean, it's like having 2xy over xz. The x is painful, but that doesn't mean the z moves up,
Okay.
right?
Yeah, we just thought it meant that pi went on the outside. Like since 2 goes into 70 equally, like the fraction isn't there anymore, and so it's just 35. Pi. But I see what you're saying. That's why we're confused.
No, the pi's in the radius. Okay, 16 degrees to radians. Pi is to 180 as something is to 16. We should never, ever miss this. So x equals 16 pi over 180. 4 goes into both of those numbers, so we have 4 pi over 45 as our answer.
I'd say that like that must have been the right answer.
That's okay, you don't have to do it the same way I do every time.
Will it still work out?
I don't know how you set it up.
I did 16 over 180 equals x over pi.
Yeah, it's the same thing, as long as the cross product is the same. You can have the ratio set up any way you want. Okay, now Max, you can turn that off, thank you, because the rest of this is already on video. Okay, now we need to look at the back side.